looking at problem 32. 6t squared, or not 6t, 6r. 6r squared minus 6r plus 12 is equal to 0. This is the problem? Okay. Now, luckily with completing the square, it will work out that we can get a solution every time. The first step in completing the square with this is we need the value for a, the number in front of r squared in this case, to be 1. So we can divide everything by 6. 6r squared divided by 6 would be r squared, minus 6 divided by 6 would be just r, and 12 divided by 6 would be plus 2 is equal to 0. Now at this point here, we need to get the variables by themselves and all the constant terms on the other side. So we would subtract 2 from both sides. And if we do this here, we get r squared minus r plus blank is equal to negative 2 plus blank. And then we need to find the value of c, which is equal to b over 2 squared, and our b value in this case is negative 1. It'll be the value in front of it. Well, negative 1 divided by 2 would be a fraction. It is a fraction. It would be as a decimal. It doesn't divide evenly. So we can leave it as that. And negative 1/2 squared is 1/4. So we can plug back in 1/4 in both places. Now our r squared minus r plus 1/4 is going to be r minus what? 1/2 is equal to. Well, we need to do negative 2 plus 1/4, negative 7/4. And again, we're going to leave it as a fraction because it's going to be easier to work with when we square root in the next step if it is a fraction and not in a decimal form. Because we're going to square root both sides. Now here the square root and square would cancel, leaving us with r minus 1/2 is equal to plus or minus. Now the denominator would be the square root of 4, and the square root of 4 is 2. Now the numerator is the square root of negative 7. Now the negative exactly would come out as I. And we would leave it as the square root of 7. Because 7 is a prime number. There are no factors, two numbers that multiply together to give me 7 besides 1 and 7. And we can't take the square root of 7. We can take the square root of 1, but it doesn't change anything. Any questions on how we got to this point? Now the next thing would be to add the 1/2 to both sides, which tells me that I have r is equal to 1/2 plus or minus I square root of 7 over 2. Or we could rewrite this, since the denominators are the same, as 1 plus or minus I square root of 7. Any questions over any of this here? Does that kind of answer your question? Yeah, this one's a little tricky because of the fact that it does pop up fractions in the dead center of it. But other than that, it will follow the exact same method. Any questions over any of this here? Any other questions on any of the homework assignments? All right. We are going to go on and continue the lesson for today. Now, we're going to do this and continue on with it because, well, we just don't have time in between finishing up this chapter and the next chapter before Thanksgiving break to be able to get it all in. Because the other alternative that we could do is that I actually give you the assignment to take home and finish over actually the chapter 4 test to finish over Thanksgiving break, and you have to work all your steps out, would be the other alternative. But what we're doing today using the quadratic formula is not an overly challenging thing, because this is the last way to solve quadratic equations. Now, the way we actually can get at the quadratic formula is using completing the square with ax squared plus bx plus c. And if we use the completing the square formula on this here, we would actually get to what the quadratic equation is. But I am not going to bore y'all with that because it really doesn't come up again. I did do it to first hour, so if you actually want to see how that works out, I did it in the first hour, well, third hour's video. And there's videos everywhere of actually completing the square on ax squared plus bx plus c, showing us how we get to the formula for the quadratic equation, which is this right here. So the solutions for any quadratic equation of the form ax squared plus bx plus c, where a, b, and c are real numbers and a is not 0, can be found by using the formula x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. And we're coming from the equation ax squared plus bx plus c is equal to 0. So let's see how this works. So we look at the equation here, because we want to solve x squared plus 3x equals 5 using the quadratic formula. Well, whenever we solve this, what does the quadratic equation need to equal? 0. It needs to equal 0. So to get this to equal 0, we can do what? We can subtract 5 from both sides, which tells me that we have x squared plus 3x minus 5 is equal to 0. Okay. This will be the only one where we specifically identify or write out what a, b, and c are. But looking at this equation, what is the value of a? 1, because it's the number in front of the variable squared. What's the value of b? And c is negative 5. So if a or b have a negative in front of it, or we're subtracting b, it will take the negative with it. Okay? Questions so far? Now the quadratic equation, or formula, is x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Negative. What's the value of b? 3. So we'd have negative, and then we'd plug in 3 for b, plus or minus square root. So we said b was 3, so we have 3 in parentheses squared because we have b squared inside the radical. Plus, or sorry, not plus or minus, minus 4 times a. What's the value of a? And then c is all over 2a. Well, a is. So what have we done so far? I just plugged in the values of what? A, B, and into the formula. Questions on this here so far? Okay, let's do some simplifying. Well, here we have negative parentheses 3 close parentheses. Well, what would that be? Negative 3 plus or minus. It'd be very tempting to type this whole thing with the square root into the calculator, the square root of 3 squared minus 4 times 1 times negative 5, and hit enter. But I believe the graphing calculator will give us a decimal answer if we include the square root. So we can't just type the whole thing in because we do need it in simplest radical form. Now it might be also tempting to just go on and type the square root of 3 squared minus 4 times 1 times negative 5 into the yellow calculator. Yeah. I did that last hour too. Tried to write with a highlighter. It gives us square root of 29, yes? Now, in the last few days when we've solved these quadratic equations, when we got complex solutions or we had a solution, an answer with I in it, well, where did we get the I from? The number inside the radical being negative, yes? Will the yellow calculators take the square root of a negative number, the TI-30XS? Well, no, they give us that error code, it doesn't work. And there's no way for us to do that. The graphing calculators will take the square root of a negative number, but if it doesn't come out as a whole number, like this here, if it had been square root of negative 29, it would have given us the decimal version of it. The graphing calculators will handle I, but won't do it in simplest radical form. The yellow calculators can handle radicals and put them in simplest radical form, but it won't deal with I. So the workaround, the way that I work around that, is I find out what's inside the radical first. So I just take 3 squared minus 4 times 1 times negative 5 and figure out what that is. Okay, it tells me it's 29. Yellow calculator, square root of 29 is square root of 29. 2 times 1 is 2. Because if it works out the number inside the radical is negative, well, we know the negative comes out as what? I, yes? So that means I can pull the negative out as I, and whatever's left inside the radical, the yellow calculator, the TI-30X, will simplify it to simplest radical form, and we have our answer. So we can utilize it, but we just have to have a step in between. Any questions on this here before we move on? So we said the square root of 29 will not simplify any further than that, yes? So can I add negative 3 and 29 or subtract negative 3 and 29? Square root of 29? Now without turning them into a decimal. Is there a greatest common factor between negative 3 square root of 29 and 2? Well, no. So we ready for the next challenging part? That's it. I cannot simplify it any further without turning it into a decimal, so that is the answer. That is the solution for this quadratic equation. Are we ready for the next one? Three x squared plus 4x is equal to 10. We're going to use the quadratic formula. So what do we need to do first? Almost. Yes, because we need this thing equal to 0. We need the equation equal to 0. Completing the square is going to be the only one really out of this. Completing the square and the square root method where we don't want the equation equal to 0. We want this thing equal to 0. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Well, what's the value of b? Four. Ax squared plus bx plus c. So b is 4 plus or minus the square root of 4 squared minus 4. Well, a is, this time, 3. And c is negative 10. And this here will be all over 2a. Well, a is 3. So we get this here. Well, negative parentheses 4, close parentheses, is just negative 4. Now at this point here, I would plug everything inside the radical, not really using the radical, to figure out what we have. And it would give us, I think it's negative something, negative 104. And 2 times 3 is? Now we do need to take the square root of negative 104, which would be negative 104 does not seem right. Yes. Because 4 times 3 is negative 12. Negative 12 times negative 10 would be 120. Plus 16 would be 136. So it should be positive. I don't know where I got negative 101 from. I think that's what I had. That's fine. And then 2 square root of what? Now, 26. This one? Well, it is 1 square root of 136 and 2 square root of 26 are the same thing. I just didn't simplify the root. This 230 or 136 is 4 times 26. The square root of 4 is 2. We leave the 26 inside. So when we simplified 4 squared minus 4 times 3 times negative 10 in the calculator, 34. Oh, okay. Yes. Okay, let's try this one more time. Because this here is 12, 120. Okay, so this is 136. And this is 2 square root of what? 34. Okay, that makes more sense. Thank you. And this is why I still do some of these here to check my work with a calculator. Because it's easy to make these little mistakes. So on these here, especially on the test, I would say write the thing out. At least, because I will show you, because there's 2 shortcuts that I do, and we'll see them on the next one. But either write the whole thing out, or with the 2 little shortcuts, write it out with A, B, and C plugged in. Because I will give you, and if I remember correctly, for how I do the points for the test, I do give you points for using the correct formula and plugging it in correctly. To where then you only lose a point or 2 for just the calculations, but you get a majority of the point for using the quadratic formula that you're asked to use. You plugged it in correctly, you have it set up correctly, so then you're only losing a small portion on getting it down to the correct answer. Now, looking at this here, is there a greatest common factor between 4, 2, and 6? 2. Okay. There's two ways we can go about doing it. I will show you the first one. Is that I can factor a 2 out of the numerator. Well, 2 factored out of -4 would be -2. Plus or minus, well, this would just be the square root of 34, and this is still all over 6. Well, 2 over 6 will simplify, won't it? To what? 1 over 3, so we're really left with -2 plus or minus the square root of 34 over 6. Questions? The other way we can look at it is, well, we're reducing everything by a factor of 2, yes? We're dividing each one of the terms by 2. -4 divided by 2 is -2, plus or minus. Well, 2 divided by 2 is 1, so we're left with 34 divided by, well, 6 divided by 2 is 3. We're just simplifying each one of those terms down. And that's really only if there is a greatest common factor among all 3. It has to be all 3. It has to be the top 2 and the denominator. If it's only 2 of them, the first number and the denominator do share a common factor, but the other one doesn't, we'll just leave it alone. Any other questions on this here? Okay, I'm drawing shapes apparently. Let's go on and look at this one here. I know I'm skipping a few, but let's look at this one here. 25x squared minus 8x equals 12x minus 4. Well, the first thing we need to do is we need to get everything on the same side of the equation. So what can we do first? Because we need this equal to 0. We can subtract 12x from both sides. Now what that'll tell us is that we have 25x squared minus 20x is equal to -4. Now again, we still need this to equal 0, so we would add 4 to both sides, which tells us that we have 25x squared minus 20x plus 4 is equal to 0. Now the first main part that we have is -b, yes? Well, what's the value of b? -20, so we're saying negative 20, so we're changing the sign of b, which would make it what? Personally, that's one thing I'll do, because we're just really changing the sign. Because we could write down negative parentheses -20, and that's perfectly fine. And since I know that we're making it negative, Well, it's already negative, so it'll become positive. If b is positive, when we plug it in, it will become what? Negative. Plus or minus the square root of negative 20 squared minus 4 times, well, a is, and c is 4. All over what? 2 times 25. Simplifying negative b and 2a are the two steps that I will simplify here. And that's all I will simplify when plugging in. Because I feel like I can do multiplication of 2 times 25, and flipping the sign with b. Any questions on this here? Well, what can we do next? We can take negative 20 squared minus 4 times 25 times 4 and see what that gives us. And it's actually 0. Because I just take what's inside the parentheses, or inside the radical first. Well, what is the square root of 0? 0, because 0 times 0 is 0. What is 20 plus 0? What's 20 minus 0? So we're really just left with x is equal to 20 over 50. Well, 20 over 50 will reduce to what? Which would reduce to 2 over 5. Because they both have a greatest common factor of 10. So it'll simplify down. Any questions on this here? We're going to look at this one here. This will be the last one that we look at solving with quadratic equations. There is one other thing we will look at. Well, to be able to solve this here, we need this here to be equal to 0. So what can we do first? Which will give us negative x squared plus 4x minus 13 is equal to 0. So here we have negative b. This is the first thing that we have in the quadratic formula. Well, what is the value of b? 4, it's positive, so when we plug it in, it would be negative 4. Plus or minus the square root of 4 squared minus 4. Well, a is negative 1, and c is negative 13 all over 2 times, well, it'd be what, 2 times a is, so 2 times negative 1 is negative 2. Now we need to do some simplifying. Which is exactly why we don't want to plug it in with the square root. We want to plug in 4 squared minus 4 times negative 1 times negative 13 first. And if we plug that in, I believe we should get negative 7. Because 4 squared is 16. Actually, it might be something bigger. Yep, times negative 13. -52. Yeah, it'd just be 16 minus 52. Negative 36. So that's why this here would give you an error if you type the whole thing in. So we want to type what's inside the radical and figure out what it is first, which is negative 36, because there is a chance that it would be negative. And the yellow calculators or the TI-30XS won't do that. But it will do it if we don't put the radical there. So it tells us it's negative 36. But we do know that the negative is going to come out as, and what is the square root of 36? So the square root of negative 36 is 6i. Any questions on this here? Now, one thing we can do with this negative now is that we can actually apply it to the numerator. Is we don't want to leave a negative in the denominator in the bottom of a fraction. So really we're factoring out negative 1 from the denominator and multiplying it by the numerator. Now negative 4 is positive. Yes. Now a negative times the positive in our plus and minus would make it negative. Well, the negative times a negative would be a So really, I'm showing you this just in case it doesn't simplify out, or if there's no divisibility, there's no greatest common factor. But there is one between all three terms, because there's a greatest common factor of, well, 2, yes? Here we could just divide, because 4 divided by 2 is 2. 6 divided by 2 is? Here it ended up simplifying out completely. We could have divided by negative 2 and got to the same spot instead of moving the negative up top. But I wanted to show you that just in case it doesn't actually simplify like that. Because if it had been 5i instead of 6i, we couldn't have done the division of 2. We would have still had to move the negative. Any questions on any of this here? We feel pretty comfortable with quadratic formula? Because really we're doing what? Plugging in A, B, and C and simplifying. Are there any questions on any of this here? The last thing we're going to talk about is the discriminant. The discriminant is the part inside the radical, our b squared minus 4ac. Now b squared minus 4ac can have 3 different types of values. It can be less than 0, greater than 0, less than 0, or equal to 0. Now if the discriminant is greater than 0, our quadratic equation will have 2 real solutions. If it is equal to 0, it'll have 1 real solution. And if it's less than 0, it will have 2 complex solutions. It's going to be one of these 3 here, depending on what the discriminant's value is. So b squared minus 4ac is greater than 0. It's a positive number. It will have 2 real solutions. If b squared minus 4ac is equal to 0, it will have 1 real solution. And if b squared minus 4ac is less than 0, it will have 2 complex solutions. So let's look at how this works. So the first one that we have is x squared minus 6x plus 10 is equal to 0. So we want to find the discriminant, b squared minus 4ac. Well, for this problem here, the value of b is So we plug in b squared minus 4. A is 1 and C is 10. Now at this point here, we could type this all into the calculator. Or if we did this here, negative 6 squared would be 36. 4 times 1 times 10 is 40. And 36 minus 40 would give us negative 4. So this is telling me here that b squared minus 4ac is what? Less than 0, yes? So what kind of solutions do we have? We have two complex solutions. That both of our answers will have I. So like the last one we had where it was 2 plus or minus 3i, those are complex solutions. Yeah, we're not actually finding the actual answers yet. In the homework, it will ask for that too. But in the entire quadratic equation, well, what's inside the square root? Well, we already found it. Any other questions on this here before we look at the next one? Here, b squared minus 4ac. Well, the value of b is still negative 6 squared minus 4. A is 1 and C is... Now we could plug this in or do it by hand. Negative 6 squared is still going to be positive 36. Negative 4 times 1 is negative 4. Times 9 is negative 0. So we have what? Real which would actually work out to be 3 if we went and solved it. Any questions on this here before we look at the last one? Well, b, they didn't change. It's still negative 6. Minus 4 times 1 times 8. Well, negative 6 squared is 36. Minus, well, 4 times 1 is 4. Times 8 is 32, which gives us 4. So we would have what? 2 real solutions. And that's really it. That's really it for this lesson. Are there any questions on any of this here? Now I'm going to go on and solve the rest of C because I want to show you that here. Where's that? Now if I wanted to finish solving C to actually find out what the two real solutions are, well, we would use the quadratic equation. Negative b plus or minus the square root of b squared minus 4ac all over 2a. Well, for us here, b is negative 6. So negative b would be positive 6 because we're changing the sign from negative to positive. Negative b, negative, negative 6 would be positive 6. Plus or minus the square root. Well, we would do b squared minus 4ac, yes? Well, do we know what it is already? Four. I just wrote it out. Yeah, I'm doing C. I just wrote it underneath B. Because we already found it, yes? Over 2 times A. Well, what is A? 1. So 2 times 1 is 2. Okay, let's go on and finish solving this here. Well, what's the square root of 4? Divided by 2. Wait a minute. Can I do 6 plus 2 and 6 minus 2? we can actually add and subtract these. That's why I wanted to look at this one here. So that means, for this problem, that really, I'm going to go on and fully simplify. We can do 6 plus 2 divided by 2. And we can also do 6 minus 2 divided by 2. Well, 6 plus 2 is 8, and 8 divided by 2 is 4. Here, 6 minus 2 is, and 4 divided by 2 is. So the two solutions for this here would be 4 and 2. Any questions on this here? Yeah. Because that would give us x is equal to 3 plus or minus 3 plus 1 is 4. 3 minus 1 is 2. It will get us to the same thing, yes. Any other questions? And that's it. There were some few others, but they were just reiterating what we've already done. Any other questions on this here?